Good morning, students. Today I will start the first unit 1. The topic is transcendental and polynomial equations. Transcendental and polynomial equations. This is your first unit. Let me define first what is meant by polynomial function. Polynomial equation. An equation of the form a naught into x to the power of n plus a1 into x to the power of n minus 1, a2 into x to the power of n minus 2, and so on, an minus 1x plus an equal to 0 is called polynomial equation. Where the quotient of x to the power of n, that is a naught, must be not equal to 0. Okay, this equation possesses n roots, right? This equation possesses n roots. For example, a quadratic equation x square minus 3x plus 2 equal to 0 has two roots. Some x cube minus x plus 1 equal to 0 has three roots. Cubic equation, three roots. And what is the meaning of the word root? The definition: root or zero. This is polynomial equation. Root or zero. What is the meaning of this? A value xi, just I am using the notation xi for the root. A value xi which satisfies the equation f of x equal to 0. That is, what is satisfies means, if I put in place of x xi, it is equal to 0. That is, f of xi equal to 0 is called root or zero of the equation f of x equal to 0. Root or zero of the equation f of x equal to 0. Now, example, if I want example, x square minus 3x plus 2 equal to 0. What is after factorization? I will x minus 2 into x minus 1 equal to 0. That implies x equal to 1 comma 2 are the roots. 1 comma 2 are the roots. A simple explanation. Next one, the multiple root. Next, see the definition of the multiple root. And before going to multiple root, let me explain what is multiple root. Multiple root definition: if the equation f of x equal to 0 can be written as f of x equal to x minus xi whole to the power of m into some function of x, g of x equal to 0, where g of x is bounded and not equal to 0, is bounded function, and g of x is not equal to 0. Bounded function and g of x equal to not equal to 0 at xi. Let me write like this: bounded and g of xi, if I replace x by xi, the value not equal to 0, then xi is called multiple root. Xi is called multiple root of multiplicity m, okay. That means m is the repetition number. What is multiplicity is called? M is called a repetition number. M is called a repetition number. repetition number. Let me explain this one through one example. If I write f of x equal to 0, the function as some x cube minus 4x square plus 4x equal to 0, which can be taken as x is common, x square minus 4x plus 4 equal to 0. So I can write this as x minus 2 whole square into x equal to 0. What is the structure? It is of the form x minus xi whole to the power of m into g of x, right? Here m equal to what? 2, xi equal to 2, and g of x equal to what? X. So what is g of 2? G of 2 means what? G of xi, that is equal to 2, not equal to 0. Therefore x equal to 2 is the multiple root, with multiplicity or the repetition number with multiplicity 2. This is about multiple root. And when xi is the multiple root, when xi is the multiple root with the multiplicity m, then the conditions are, then see what is that? Xi is the root, so f of xi is 0, and since it is m times repeated root, f dash xi, f double dash xi, and up to m minus 1th derivative at xi, all are equal to 0, and f mth derivative xi not equal to 0. See, for example, in this example, what is the f of x equal to what? X cube minus 4x square plus 4x equal to 0. What is the root? 2. F of 2 0. What is f dash x? F dash x is 3x square minus 8x plus 4. So what is f dash 2? F dash 2, this is 9. F dash 2 4, 4 3 is 12 minus 16 minus 4 plus 4 0. And what is f double dash 2? F double dash means what I am having, 6x, 6 into 2 minus 8, which is not equal to 0. This is the concept. So what is the thing? Multiple root means it has a repetition number. Xi is the multiple root with multiplicity m, means xi is a repeated root and it is repeated m times. Okay, when it is repeated m times, the function value and its m minus 1th derivatives at the root is 0 and mth derivative is not equal to 0. Okay, this is about multiple roots. Now what is the main aim of this chapter is, if f of x equal to 0 has a root which is determined by exact methods, or which are also called as direct methods. That is, if f of x is, for example, a first degree polynomial, then what is x equal to minus a naught over a1? This is direct formula. If f of x is ax square plus bx plus c equal to 0, quadratic equation, then what are the roots? Minus b plus or minus under root of b square minus 4ac over 2a. Okay, these are called exact methods. This one exact and this one exact method. They are using direct formula. Exact methods or direct methods. If, for example, f of x is higher degree polynomial, Same, for example, f of x equal to some x to the power of 99 minus x to the power of 50 plus some 50 equal to 0. How to find the root? How to get a root? That's the question mark. Okay, that means in general up to second degree, third degree, it is possible to find. For third degree also, in sometimes it is possible to find all the roots, but if it is complicated equation, maybe higher order equation, third order, fourth order, fifth order, 99th, 100th order equation, it is not possible to get exact root of this equation. So if it is not possible, if it is not possible to get exact root of these equations, higher degree equations of these equations, then we go for approximate roots. Then we go for approximate roots. Okay, this is in case of higher degree polynomials. Next one is if f of x equal to 0 contains trigonometric functions or logarithmic functions or exponential functions or combination of these, it is called, or it is named as transcendental equation. It is named as transcendental equation. Example, x into sine hx equal to some 2, or x into e to the power of x equal to cosine x, some log x to the base 10 minus 1.2 equal to some e to the power of x, etc. These are all transcendental equations. Which involves transcendental equation means an equation involving trigonometric, logarithmic, exponential function is called transcendental equation. Then how to find an approximate root of these equations? Approximate root of these equations. Okay, this is the main idea of this chapter, finding an approximate root of the higher degree polynomial or transcendental equation. So what is our equation? So our equation is f of x equal to 0. Maybe this may be polynomial equation, this may be polynomial equation or transcendental equation. Then what is the question? How to find root? Question, finding an approximate root. Finding an approximate root of this equation. Okay. First, let us see direct methods. Direct methods. These methods gives exact root of the equations. These methods give exact root of f of x equal to 0. As I told previously, in linear case, that means a0 plus a1 x equal to 0. That implies x equal to what? Minus a0 over a1 is the root, is the exact root. In quadratic case, second degree polynomial, what is ax square plus bx plus c equal to 0? Means x equal to minus b plus or minus under root b square minus 4ac over 2a. Okay, and The next one is, these are the direct methods, simple, up to quadratic equation only direct formula is available. Next one, if I go for iterative methods, iterative methods, what iterative methods states that these methods based on successive approximations. What is meant by successive approximation? Assume initially one approximate, then improve this one by taking more number of iterations. That is what, starting with one or more initial approximations, to the root, and get a sequence of approximations, or which are also called as iterates, sequence of approximations xk, which in the limiting case converges to exact root xi. Okay, iterative methods means what? For example, let x naught be the initial approximate root of xi, then iterative methods gives the successive approximations x1, x2 and so on, dash xk and so on. Okay, such that limit k tends to infinity xk goes to xi. Limit, how to calculate limit from the intermediate level. Limit of xk tends to xi. Okay, this is iterative methods. That means start with one particular initial approximation x naught, then apply some method, iterate. There are so many iterative methods are there. Further you will get bisection method, Newton-Raphson method, regular falsy method and so on. In those methods, take initial approximation as x naught, and applying the method you will get successive approximations x1, x2, xk better than x naught and so on. And when this k value goes to infinity, that means x1, x2, x3, xk, x100, x1000, x1 lakh and so on. In the limiting case, this approximate root tends to exact root. This is the concept of iterative methods. Now, if limit k tends to infinity, xk equals to xi, then the sequence of approximations xk said to converge to the root xi. This is convergence definition. The approximate roots tends to convergence to the root xi if limit of xk as k tends to infinity equal to xi. another point. Now if xk minus 1, xk minus 2 and so on, xk minus m minus 1, xk minus m minus 1 are the m approximations, or the m approximations to the root, m approximations to the root xi, then a multi-point iteration method, a multi-point iteration method, multi-point iteration method is defined as xk plus 1 is equal to phi of xk, xk minus 1, xk minus 2 and so on, xk minus m plus 1. This is multi-point iterative method. What is the meaning of this multi-point iterative method? See, that is k plus 1th approximation, k plus 1th approximation, I will write approximate directly like this. Approximation depends on it's a previous approximation, it's a previous approximations. This is called multi-point iteration method, and phi, the function phi is called multi-point iteration function. Phi is called multi-point iteration function, okay. If m equal to 1, what this becomes? If m equal to 1, what this becomes? xk plus 1 equal to simply phi of xk. When m equal to 1, if I take 1 here, if I put 1, this becomes xk. That means only one term will be there. This is called one point iteration method. Now the most important point is now how to choose the function phi in iteration method. This is the most important one, how to select the function. Okay, see, for example, to understand this concept clearly, let me consider the quadratic equation. What is the, let's consider the quadratic equation ax square plus bx plus c equal to 0, where a not equal 0 for the quadratic second degree polynomial. And here how many types of functions I can write from this ax square plus bx plus c. See, ax square plus bx plus c equal to 0 implies, let me write first bx equal to minus ax square minus c, and what is x equal to minus ax square minus c over b. This is one function, okay, minus b. And from this I can write xk plus 1 is equals to minus axk square minus c by b. This is one choice, okay, this is one choice. Next one, another one, ax square plus bx plus c equal to 0 implies, I will write this one ax square equal to minus bx minus c, or x equal to minus bx minus c over ax. That implies, what is the iterative formula become? Xk plus 1 equal to minus bxk minus c by axk. This is another function, another logic. Ax square plus bx plus c equal to 0 implies implies, let me write the another way, ax square plus bx equal to minus c, right? From this left side x is common and the remaining is taken onto right side, that means ax plus b. From this I can write xk plus 1 is equal to minus c by axk plus b. This is another chance. Here what is phi of xk? It is the right side minus axk square minus c by b, or phi of xk is what? The second function minus bxk minus c by axk, or what is phi of xk? The last function minus c by axk plus b. Okay, these are the three functions. So which is the better? Which is the better function for phi or phi of xk? This is the question mark. Okay, this is we will study in convergence analysis of the iteration method. So which function gives better results, best results, that means best successive approximate roots to the exact root xi. Now to start iterative methods, first we need initial approximation. Okay, using this initial approximation we find the better approximation, successive approximations, by using iterative methods. Initial approximation by using the well-known theorem, intermediate value theorem. Okay, what is the statement here? Intermediate value theorem statement is you must remember this statement: if f of x is a continuous function, means the function is defined everywhere, continuous function on closed a comma b interval, continuous function, it is defined everywhere of the point closed a comma b, and what is the condition here? F of a into f of b less than 0. That is what? F of a, f of b are having opposite signs, this is sign, opposite signs, then there exists at least one root, over the interval, open a comma b, there exists at least one root over the interval open a comma b. This is intermediate value theorem. Okay, so this is the one root over the interval a comma b, or that is, one can extend this one, there exists a root xi such that f of xi equals to 0. Let me explain graphically this one. See, what is this? What is the equation? F of x equal to 0. Explanation for this: f of x equal to 0 is the equation. Okay, defined over the interval closed a comma b. Assume, what is the condition? Assume f of a and f of b both are having opposite signs. I am taking this is less than 0 and this is greater than 0. So what is the pictorial representation of this one? This is x-axis, this is y-axis. Okay, and this is, let me consider this is a, and let me draw This is x-axis, this is the point A, and this is the point B. Okay, f of a negative means what? F of a means what? This y equal to f of x. Y is nothing but f of x. Okay, if y value f of a means negative, this is f of a. So the point is what? A comma f of a point is here. This is capital A, and f of b is positive somewhere here. This point B is b comma f of b. F of b positive, so it lies in first quadrant, and f of a means y. Y is negative means in the fourth quadrant. Then what is the curve? Curve is continuous function. Continuous function means if I join A and B, there is no cutting point. It is continuous everywhere where this curve intersects x-axis at this point. That is called psi. So when f of a negative, f of b positive, when both are having opposite signs and curve is continuous, definitely curve intersects x-axis at a point. That point is called root. This is called intermediate value theorem. Sometimes it is also named as intermediate mean value theorem. Now let me explain this intermediate mean value theorem through an example. Let f of x equal to some x cube minus 3x square plus 1 equal to 0. Okay, let me start with, you can start with any real number for x value. If I consider 0, f of 0, this is 0 minus 0 plus 1 equal to 1 positive, and f of 1, if I take 1 minus 3 plus 1, that is equal to negative 1 less than 0. Since f of 0 into f of 1, now what is this? Less than 0, the root of f of x lies between 0 and 1. That means xi belongs to what? 0, 1. This is one example. Okay, another example, let me consider one transcendental equation. What is this? F of x equal to cosine x minus x into e power x equal to 0. Remember, whenever trigonometric function is there in the equation, then you consider x in terms of radians. Take x in terms of radians. In calculator, it will be there radians, in terms of radians. So what is f of, let me consider 0. This is cos 0 minus 0. Cos 0 value 1, that is positive, right? And f of 1 radian, this is cos 1 minus e, x into e. Let me consider 0.5 for example. Since we are getting positive and negative, if I minimize the length of the interval, that is better. 0.5 cos 0.5 minus 0.5 into e to the power of 0.5, and this value is 0.0532. It is also positive. Now let me consider 1. This is cos 1 minus e to the power of 1, and this value is minus 2.1780, which is negative. Therefore the root xi belongs to where? 0.5 to 1. Xi belongs to 0.5 to 1. This is called locating the interval, where initial approximation belongs to this interval. Is that clear? Okay, this is first. In iterative methods, the first step is always locating the interval.